Alright, so we got 2018 number 2. An environmental science teacher at a high school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. The teacher selected a random sample of students at the school to survey. Each selected student went into the teacher's office one at a time and was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval for the proportion of all students who would respond yes was calculated as 0.584.816. Question A. How many students were in the sample selected by the environmental science teacher? Alright. So we're dealing with a one proportion confidence interval here. The equation that's relevant to us is this one. The margin of error is the critical value times the square root of p hat q hat over n. We know it's 95% confidence interval. So we know that our critical value is 1.96. The other things, the margin of error and p hat, we're going to have to calculate from the interval that they gave us, which was 0.584 to 0.816. A couple of ways you could do that. You could subtract those and get twice the margin of error and then find what's in the middle. Or you could just find what's in the middle. If you go 0.584 plus 0.816 over 2, we get p hat equals 0.7. And then how far is it from 0.7 to 0.816 or 0.7 to 0.584? And that's 0.116. Alright, so now let's plug this stuff into there. 0.116 equals 1.96 p hat q hat, and solve for n. Squaring multiply by n, divide by 1.116 squared. And we get 59.95. Round to the nearest whole number because this is a sample size. You're not going to ask 95 hundredths of a person. And we get a sample size of 60 students. Part B. Given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how the bias might affect the point estimate of the proportion of all students at the school who would respond yes to the question. So the important bits here is that right there. The teacher's calling them into the office, and like recycling is what you're supposed to do, and you're talking to an authority figure, or like especially an environmental science teacher. Like you might be embarrassed to say no, essentially, is the idea. That's how bias might have been introduced. And describe how bias might affect the point estimate. So it might affect it by it's essentially, we think that it might be too large. More people would be inclined to answer yes, and the point estimate would be higher than the true proportion. So let's write some of that stuff down. Bias is introduced. Since they're talking to are interviewed individually. By the environmental science teacher. And students would be reluctant to say no, or embarrassed to say no, or something like that. And students this will cause our point estimate to be too high. Alright, C. The statistics teacher at the high school was concerned about potential bias in the survey. To obtain a potentially less biased estimate of the proportion, the statistics teacher used an alternative method for collecting student responses. A random sample of 300 students was selected, and each student was given the following instructions on how to respond to the question. In private, flip a fair coin. If heads, you must respond no, regardless of whether you regularly recycle. If tails, please truthfully respond yes or no. What is the expected number of students from the sample of 350 who would be required to respond no because the coin flip resulted in heads? So if this is a fair coin, we should have a 50-50 probability of heads or tails. And 0.5 times 300 is 150 students. For part 2, the results of the sample showed that 213 of the 300 selected students responded no. Based on the results of the sample, give a point estimate for the proportion of all students at the high school who would respond yes to the question. Okay, so we got a bunch of stuff going on here. We got 300 students. We expect just 150 no's based on coin flips. And 150 that are telling the truth. Alright, so we had 213. I expect 150 of those are from the coin flip. That means I will expect 213 minus 150. Which is 63. And we had 87 yeses. So this, essentially, is the sample that we're dealing with. So 87 out of 150. Is 0.58. And that is our point estimate. And that's that.